This is an Algebra 2 class, and today we're going to be looking at multiplying and dividing rational expressions. When multiplying two or more fractions, we know that any numerator can be reduced with any denominator. And to reduce, we have to look for common factors. So to warm up, we need to send our minds back to 7th or 8th grade when we talked about common factors. So our first question as we look at this is, what is the greatest common factor of 24 and 30? That is, as we look at 24 and 30, what is the largest number that divides into both of those? And that greatest common factor would be 6, because 6 times 4 is equal to 24, and 6 times 5 is equal to 30. So the common factor, the factor that they have that is the same, is 6. Now, when we multiply fractions, we can actually reduce all the common factors before we actually multiply. For instance, if we had the fractions, the rational expression 2/3 times 6/5 times 25/4, and we want to multiply that, the first thing that we could do is reduce common factors. For instance, I know that 2 and 4 have a common factor of 2, so I can reduce these two factors by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. We also see that 3 and 6 have a common factor of 3, so I can reduce each one of those by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. Finally, we see the same thing with 5 and 25. They each have a common factor of 5, so reducing by 5. 5 divided by 5 is 1, and 25 divided by 2, divided by 5 is 2. So as we multiply now, what's left over in our numerator, we have 1 times 2 times 2, which is 4. In our denominator, 1 times 1 times 2 is 2. We actually could have reduced those right here as well. 4 divided by 2 is just 2. So this product of these three fractions multiplies out to just be 2. With rational expressions involving binomials and trinomials, we have the same principle apply. We need to look for the factors and then reduce the common factors, and finally multiply the remaining factors. So let's take a look at this next example here. We have 20x minus 5x squared. This is a binomial. We can factor out a common factor for these two terms. A common factor is 5x. So in our numerator of our first fraction, we factor out 5x, leaving us with 4 minus x. And in the denominator of that fraction, we again have a binomial, has a common factor of x, so it factors to x times a quantity, x minus 1. In our second fraction, it's a trinomial. It's going to factor into two binomials. X squared is x times x, and the factors of negative 4 that add to 3 are positive 4 and negative 1. Now in our denominator, we have x squared minus 16. It's a binomial. It's a difference of two squares. So it factors to x plus 4 and x minus 4. Let's go ahead then and reduce the common factors that we know. Here our numerator 5 times x. The 5 is a factor and so is the x. We see that we have a common factor of x. So we're going to reduce x divided by x, and in each case we're left with 1. We also see an x minus 1 in the numerator and the denominator, so we're going to divide those, x minus 1, leaving us with just a factor of 1. We also have a factor of x plus 4 in the numerator and denominator, and those reduce as well. Now let's take a look at what we're left. We're not quite done, but let's take a look at what we have left. We now have the factor 4 minus x and the factor x minus 4. Those are kind of interesting factors. In fact, I can take a look at this numerator and I can rewrite it in standard form. I can rewrite it as negative x plus 4, and I have x minus 4. We see our leading coefficient here is negative, so we can factor out a negative 1 out of the numerator and get a new expression. Factoring out a negative 1 out of the numerator leaves us with x minus 4. And notice when I do that, we now have a common factor of x minus 4, and those reduce, leaving us with negative 1. We went through a lot of steps to get there, but if we go back up to this step and recognize that 4 minus x and x minus 4 are just opposites of each other, we know that they're going to reduce to get negative 1. Okay, let's take a look at our next example. In our next example, we have two rational expressions. The second one doesn't look like a rational expression, but it is because it can be written as being over 1. Now, as we look to do the factoring, in our first fraction, our first expression, x plus 2 doesn't reduce. There's no common factors between x and 2, so we're going to leave it as x plus 2. In the denominator, we have x cubed minus 27, which is a difference of 2 cubes. And we need to remember how to factor a difference of 2 cubes. Our rule for a difference of 2 cubes is when we have a cubed minus b cubed, it factors to the binomial a minus b multiplied by the trinomial a squared plus ab plus b squared. So let's go ahead then and factor x cubed minus 27. X cubed minus 27 is x cubed minus 3 cubed. So we can factor that to x minus 3 multiplied by x squared plus 3x plus 9. And then our second fraction is x squared plus 3x plus 9 over 1. We see that they each have a trinomial, the trinomial factor x squared plus 3x plus 9 in common, so those two can reduce, and we're left with x plus 2 divided by x minus 3. Now, when we come to doing division, division really works the same way because we're going to change a division problem to multiplication. In division, we change the division to multiplication by the reciprocal of the divisor. So in question number 5, our first fraction, 7x over 2x minus 10, stays the same. And our second one is the reciprocal, which flips upside down. So we have x squared minus 11x plus 30 over x squared minus 6x. Now we want to factor just like we did before. 7x is really two factors. It's the factor 7 and the factor x. And in our denominator, we have a common factor of 2. So factoring out the 2 gives us 2 times the quantity, x minus 5. And in our second expression, we have a trinomial, which factors to 2 binomials. We have x minus 6 and x minus 5. Negative 6 times negative 5 multiplied to positive 30, and the outer and inner terms, negative 6x and negative 5x, add to negative 11. In our denominator, we have a common factor of x, so we factor out the x, leaving us with x times the quantity, x minus 6. And now we're ready to do some reducing. So as we look at that, we see in our numerator a factor of x, and in our denominator a factor of x. So those two reduce, leaving us with just 1. We also have a common factor of x minus 5 in the denominator and in the numerator, so we reduce those. And finally, we have a common factor of x minus 6, reducing those. When we multiply out in our numerator, we have 7 times 1 times 1 times 1, or just 7. And in our denominator, 2 times 1 times 1 times 1 again is just 2. And so we end up with the fraction 7/2. Let's try another example. Again, it's division, and we switch it to multiplying by the reciprocal of the divisor. So our first fraction stays the same. Our second fraction, that fraction we're dividing by, becomes multiplied by 1 over 3x squared plus 5x. And now we're ready to do some factoring. So we have the trinomial that we're going to factor into two binomials. To get 6x squared, it's going to be 2x and 3x. To get negative 15, we're going to have 5 and 3, with the 3 multiplied by the x and the 5 multiplied by the 2. Our outer term would give us 10x, our inner term negative 9x, to add the positive 1x in the middle. In our denominator, we have 4 times x, 4x squared. And then in our other fraction, we have 1 and a common factor here of 3x. So 3x multiplied by x plus 5 in our factored form. Now as we take a look, oops, no, we don't have 3x. We have just x, and in our parentheses, we have 3x plus 5. Okay, I said that one incorrectly. So common factor of x, and then in our binomial, 3x plus 5. Now when we look for common factors, we do see a common factor of 3x plus 5. It's a good thing. Dividing each numerator and denominator by 3x plus 5 leaves us with just 1. And that is the only common factor we have. So now we're ready to multiply out. In our numerator, we have 2x minus 3 multiplied by 1. So just 2x minus 3. In our denominator, we have 4 times x times another x, giving us 4x cubed. And that is our simplified fraction. So that's how we multiply and divide with rational expressions.